Okay, guys, today we are going to solve this problem. The problem here is in a survey of 3,196 adults, it was found that 84.7% of them used at least one prescription medication. Construct a 90% confidence interval estimate of the percentage of adults who use at least one prescription medication. Okay, so first of all, we have to check the requirement to construct a confidence interval to estimate a population proportion. So let's check the requirement, okay? Check the requirements. The first one is the sample. It must be a simple random sample, and we assume this sample of 3,196 adults is a simple random sample. Okay, so this is a simple random sample, and in number 2, the condition for the binomial distribution must be satisfied. Okay, so what are the conditions for the binomial distribution? The first condition is there should be a fixed number of trials, and you see here we have a 3,196 adults, so which is the fixed number of trials, right? So the first condition for binomial distribution is satisfied, and the second condition is this should be independent. All right, the trials should be independent, and you see the response from one person does not affect the probability of the response from another person. So we can claim that the trials are independent. And for the part C, there are two categories of outcomes, and here if you look at this problem, you can find that the subject used at least one prescription medication or does not use the prescription medication at all. Okay, so there are two outcomes. So now you see like the requirement test has been passed by this problem. So now the next thing is we have to find out the 90% confidence interval, and the 90% confidence interval is given by the confidence interval, right, to estimate population proportion P is P hat minus E is less than P is less than P hat plus E, where E is the margin of error, where E is the margin of error, right? So margin of error, and you guys know that the margin of error is given by E equals to Z sub alpha over 2 square root of P hat times Q hat over sample size n, and this Q hat is 1 minus P hat. So this is the formula to find the margin of error. So what we need here is, so let me write down this formula on the top. Okay. So the margin of error, you have E equals to G sub alpha over 2 square root of P hat times Q hat over N. And you know this sample proportion, this P hat is 84.7%, right? This is 84.7%, which is 0.847. Then this Q hat is defined as 1 minus P hat, so which is 1 minus 0.847, right? So it's going to be 0.153, 0.153. And you guys know that we have the fixed number of trials, which is N, is given by 3,196. So next thing we have to find is G alpha over 2. So we are trying to construct a 90% confidence interval. Let me write down here. So the confidence level, which is 1 minus alpha, this is the probability 1 minus alpha, is equal to 90%, which is 0.9, right? So from here, if you solve for alpha, then alpha is going to be 0.1, but you need the value of alpha over 2, so you divide both sides by 2, then alpha over 2 is equals to 0.05, right? So you need to find the value of Z alpha over 2. So you have every information, right? So you have a P hat, you have a Q hat, which is 0.153. You have the fixed number of trials. So if you can find the value of Z alpha over 2, then you can just plug in the value and do the computation. So how to find Z alpha over 2? So if you look here, guys, so this is Z alpha over 2 here is exactly Z, and you just found the value of alpha over 2, which is 0.05, right? So what does that mean? So that means you have the density curve for the standard normal, right? This is your density curve, and this is G 0.05. So that means area to the right of G.05, this area, okay guys, so this area, let me denote it by A, is 0.05. So the area of this, let's say this area of this red shaded region, did you see that? Yes. So the area of the red shaded region is 0.05, but this Z score is the value that corresponds to the left of the density curve, right? So now we need the area of this region. So we need the area of this region, and the area of this region is 1 minus 0.05, right? So 1 minus 0.05, and which is 0. So this is going to be 1 minus 0.25 is 0.95. So this is 0.95. So then we use the technology, and I prefer to use the calculator. So so if you use the calculator, we will get this G value equals to 1.64. Right, so by using the calculator, we got the Z.05 equals to 1.64. Now in this formula, we knew the value of Z alpha over 2, which is 1.64. We already knew the value of P hat, which is 0.847, and the Q hat is 0.153, and we knew the sample size, which is 3,196. So let's plug in those values in this formula. So we figure out Z alpha over 2, which is Z alpha over 2 is G, right? 0.05. This equals to 1.64, right? So let's plug in this information in our formula. So we will get, so it will be what? So Z.05 is 1.64, right? And radical, what is my P hat? 0.847 times, what is my Q hat? My Q hat is 0.153, right? And divided by, what is my N? 3,196. So if we do the computation, so we will end up with, this is going to be 0.01, right? So now we got the value of E, which is the margin of error. E is the margin of error, which is 0.01. So now we have the value of margin of error equals to 0.01, right? So we got 0.01, and you remember the confidence interval to estimate the percentage of adults who used at least one prescription medication is given by P hat minus E is less than P hat plus E. So this is the confidence interval, right? So we know the value of P hat, which is 0.847 minus, and we also knew the value of margin of error, right? We also know that, which is 0.01 is less than P is less than 0.847, this P hat plus the margin of error is 0.01, okay? So now this gonna be what? So this is if you subtract 0.01 from 0.847, you will get 0.837 is less than this P, less than 0.857, okay? And now if you write the answer in a percentage, so this gonna be 83.7% is less than P is less than 85.7%, okay? So this is the 90% this, okay? So this is the 90% confidence interval estimate of the percentage of adults who used at least one prescription medication. So this is your final answer. Okay, thank you guys, have a good day.